Greg Mitchell, I work at the Scripps Institution of Oceanography. That's a department of the University of California, San Diego. And I'm a research scientist, and my focus is algae physiology and ecology. I've been studying algae since I went to graduate school in 1978, and my expertise is in algae and physiology and photosynthesis, especially aquatic microalgae. Well, right now the price of production is very high. We know we can grow algae at very high yields, and so I think that we really need to create some sort of interface between the basic science and academic side, industry, and the public side to create larger consortia and to go to a pilot scale. And for that, I'd say we need to be in the 5 to 20 acre scale of production facilities where we're really working through all the problems end to end. And this is going to take some time. It's going to cost some money. And I think there's going to have to be a strong public sector support for this to attract the private sector investment. One of the more important things is that while I think that there are many policymakers recognizing the challenges that lie ahead of us in terms of fuel energy security or food and water security, in some cases the policymakers are trying to choose the winners. I think there needs to be parity in the space. I think that from an algae perspective, we need to really recognize its potential role as well, not only in biofuel opportunity, but also as potential biomass production for animal feeds and a way to produce more biomass per unit of fresh water, because we have a water crisis on Earth as well as a petroleum crisis looming. Certain regions in the world, it's probably going to be impractical because you're not going to have a water source to actually grow algae, and that's going to be the same for agriculture in some of those regions. But algae can grow on saline water or wastewater coming that we normally throw into the ocean or our rivers. And so there's a lot of ways we can utilize either wastewater, dairy, feedlot downstream, or saline water. And so these are things that aren't being used for traditional agriculture or potable water for humans. And so the fact that algae can utilize these other water sources will be a huge benefit. Well, I think that with the momentum we've built in the last 4 or 5 years, I'm feeling pretty comfortable, more comfortable than I was a few years ago, that society understands the potential and the policy makers are recognizing it. And I think they're going to create some reasonably stable funding coming from the private sector, from the public sector, that's going to also leverage private sector money for the next 5 to 7 years. And so what I see in 10 years is we're going to be pushing algae farms to the scale of 30 to maybe 100 acre scale, and these are going to be operating around the world, not just in the United States. Many countries are investing now. So what I'm really hoping is there's going to be this international race to get bringing the costs down at the scales of 30 to 100 acres, where you really can be working through a major pre-commercial but demonstration size. And so I think we're going to be there in 10 years, and then once we can show that we're going to bring the prices down, I think we'll be rolling it out. If I was going to snap my fingers right now, we would have something within 30 minutes of my lab at Scripps, and it'd be on at least 20 acres, and it'd be funded for 10 years. And if we had that, I think we would solve most of the problems within 10 years. And collectively, not me alone, but the right team working for 10 years with stable funding on 20 acres, we would come forward with a lot of breakthroughs and solutions.